So I just wanted to do a quick video here of some common limit situations that aren't going to work with our typical technique. Some of them do, just some things that we maybe aren't prepared or aware of. So I wanted to start focus on the absolute value. So here we have the limit as x approaches 8 of the absolute value of x minus 8 over x minus 8. Now, if the absolute value weren't there and we just had this equation, x minus 8 over x minus 8, that would be equal to 1 unless x was equal to 8, because we can't divide by 0. So just going to keep that in mind. This if the absolute value wasn't there, this would be 1. It would be silly. The limit would be 1 because it would just be a hole there at 8. So it's just a little bit funky. It's 1. But with the absolute value, it becomes a crazy situation and gets a little bit more complicated. What we know about the top of this is that it's always equal, the absolute value of x is equal to x minus 8 when x is greater than some number. We'll come back to that. Either they're exactly the same or they're the opposite, right? Because either the stuff inside is going to be positive already and we won't have to change the sign, or the stuff inside was negative and we changed its sign. So when does that change occur is kind of what we're kind of focusing on here, is what is that, and that's not supposed to be 0, so just why I use lines the first time. What is that number that's really important? Well, it happens to be usually where we're going to take our limit at. So since it is 8, at 8 is where they switch. So basically you have these, and the reason I put my camera on today, you have these two line segments that this is what the graph looks like every single time. So here's a picture of the graph. It always looks like this. A flat line here and a flat line there. Every now and then they get a little creative. They'll maybe times something by 2 so that it would be 2x minus 8, 16. Oh, maybe an absolute value over x minus 8. And that's still just going to either be 2 or negative 2 because we just times 1 by 2. And so that didn't change anything. It just seems like it changed something. So those are your basic ideas. It's always going to be, the answer of this is, depending on what you're looking at, it's going to be 1 or negative 1. So again, when we look at this, when we look at our left-handed limit, we are approaching negative 1. That's our left-handed limit. That's where we're headed. And specifically this picture, those are both open circles because x cannot be 8. So we're going to negative 1, and up here we're approaching positive 1. And so for this limit doesn't exist because the left-handed and right-hand limits don't agree, or the left side is at 1, negative 1, and the right side is at positive 1. Be very careful, because if I said, hey, what's the limit as x approaches 7 of the exact same equation, well, then it's 1. So be careful. Always try direct substitution first. On this problem, we get 0 over 0. If that happens to you, then move on and see what happens next if you were to kind of consider this whole thing, because that's what an absolute value graph like this is doing. So just keep that in mind. It's a really important one. They throw it at us all the time. It's a very thinking problem rather than anything else. The other one I wanted to talk about was this one. How do I find this limit of x minus 2 over the square root? So anytime there's a weird square root limit, I know I demonstrated this in class, but I still think it comes up, is whenever you have square roots, it makes the algebra harder, but we still can only multiply by 1. So I know sometimes I look at some problems and I'll have the square root of a mess or the square root of a mess, and I think, oh, I'll square it. But you can't do that because we don't have an equal sign. So the only thing we can do when we're manipulating problems in calculus, most of the time, because we don't have equal signs, we're not trying to solve, we're trying to manipulate. And so the only thing we only have two choices: times by 1 or add nothing. Adding nothing can look really complicated. Timesing by 1 can look really complicated. But those are the things we're doing all the time. So when you're thinking, it's so crazy, it's always the same thing. It's just, it is crazy because the calculus got insane. The algebra got insane, but we are not calculus. We don't have to do much insane calculus, so that's good. The algebra gets really intense here but we can only multiply by 1. And we want to multiply by 1 so that things are nice. So we're going to do square root of x plus square root of 2. And the reason we do that is because that conjugate pair bit will help the middle terms become 0. So think about our lovely the only kind of factoring where the middle was 0 kind of our remembering. Oh, x plus 2, x minus 2, because the middle goes away. So that's kind of what we're doing here, is kind of forcing that relationship. So it's an important relationship. It's what we're kind of forcing it. So we're going to put some parentheses around stuff so nothing disappears or behaves funny. All right, I only am going to multiply through where my radicals are. I will not be multiplying the numerator. So I still have a limit because I haven't done anything with it, of x as x approaches 2, of x minus 2 times the square root of x plus the square root of 2. Excuse my voice, I haven't used it very much today. And then in the denominator, I'm going to have these multiplications. So I'm just going to kind of go over here. I'm going to do a quick little note because it's not really part of my problem. I'm going to do the square root of x minus the square root of 2 times the square root of x plus the square root of 2. And so, closing my parentheses, I get square root of x times the square root of x is x plus 2 radical, the square root of 2 times the square root of x plus, minus the square root of 2 times the square root of x. Sorry this sign kind of blended into my radical. Then plus, minus, I misspoke, minus 2. And so what I have in the denominator is x minus 2, because these two make 0. Sticking that in some parentheses, magic, 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 goodbye. Now I have limit as x approaches 2 of the square root of x plus the square root of 2. And I go ahead and plug in 2, and so I get the square root of that 2 plus the square root of 2, or 2 square roots of 2, because there's 1 plus 2. And there's my answer. Notice some notation here. So notation, again, is the way we write math down. I used, my limit is here until I used it. Once I used it, the limit is no longer written down. So be really careful about that. Don't write it down too long, and don't stop writing it too soon. Then you have this. I didn't want to keep writing the fraction while I simplified. I didn't want to do that and make it all complicated. So I kind of stuck it in a sidebar note. And it's important because we're going to do that. And hopefully eventually you'll get really good at this and you won't even need to write that down. But if you don't, you're going to be doing this kinds of quick hit things all the time. So just because you don't want to overcomplicate the mathematics, okay, or the fraction, because with fractions you have to keep writing it down every time, and when nothing's happening on one part, it's really irritating. Okay, so that one's pretty straightforward once you remember to multiply by 1. My high school calculus teachers used to say we're going to multiply it by a clever form of 1. I've taken that to be like the sneaky one that we just need to, there's a sneaky one we're trying to find, and then last year somebody called it a ninja one, which I think is really cool because, you know, ninjas. Here we go. So anyway, take it out for what it's worth. All right. So then this one was in your WebAssign, and we hadn't had a chance to talk about it. I put it on WebAssign knowing that we hadn't had a chance to talk about it. I do sort of apologize for that. Mostly I wanted to see if I could push you and challenge you in this problem. But I also don't know that I have time to talk about it in class, so I wanted to go through it really quickly. We're going to expand this, and so I'm going to do a note because I don't want to keep writing this. So this is just, I'm playing with the numerator. So I'm going to expand this, and I'm going to, I know I square the left. Oh, let me do this a little slower. X plus delta x quantity squared is equal to x plus delta x times x plus delta x, because you're going to do this incorrectly, because every year, always, kids do this incorrectly and make their teacher crazy. So we have x squared plus x times delta x plus x times delta x plus delta x squared. Okay, so that's that beginning expansion. See why I wanted to do this on not in the middle of the fraction? It's a mess. I'm going to go ahead and distribute the -8 through this. 8 delta x. I'm going to just write the plus 5. I'm also going to distribute this minus sign. Let me change colors. Distribute the minus sign, minus 5 through just the minus sign. So minus x squared plus 8x minus 5. Okay, so I'm going to clean everything up. So the first thing I see is that I've got x squared and negative x squared. Goodbye. Then I notice that I have negative 8x and negative 8x. Goodbye. It's really important. Then I have 2x times delta x plus delta x squared minus 8 delta x. Oh, wait, I missed these two. These two also go away. So that's all I'm left with. That was really clean. That's really nice. That's much nicer. So I'm going to write delta x on the bottom because I haven't done anything with that. I'm done with my note. Okay, so I'm going to put my limit back on. And by doing the note, I don't have to keep writing the fraction the whole time. I don't have to keep manipulating the whole time. I can just play. And so I'm going to go ahead and factor now. This is a little weird, but I'm going to take a delta x out of the numerator. So delta x, 2x plus delta x minus 8 all over delta x. I still have my limit. It hasn't gone anywhere. But these cancel. And so I'm left with the limit as delta x goes to 0 of 2x plus delta x, minus 8. And you can't really see that. Let me get something behind it. Whatever, we'll just leave the line there. And so then I'm going to plug in 0. Now I'm going to do a direct substitution. It wouldn't work earlier, but now that I've manipulated it, it will. And so I'm left with my final answer of just plugging in 0, and I've used the limit now. This is my answer. And so sometimes x is part of your answer. And remember what's happening here when we think about delta x, don't forget where it came from. So in our very beginning of life, we'll come back to this in just a second, we were doing delta y over delta x. That was when we were first introduced to the symbol delta. What does this represent? Change in y over change, I can't even help myself, change in x. And as we take the limit of anything with delta x on the bottom, as delta x gets small, what we're doing is we're going from average change to instantaneous change. We're going from average to instantaneous because delta x gets smaller and smaller and smaller. There's less change in time. So if we can make that 0, we have instantaneous rate of change. And what is rates of change? Rates of change are slopes. So if we can get to instantaneous rate of change, which we did for this mess, we found the instantaneous rate of change. That's what we did. So it's really important. We're going to talk about this some more. It really leads into our next chapter. We're going to spend a lot of time on this. These problems like this are going to crop up everywhere. So just be prepared for them. They're algebraic crazy things. And then eventually, sometime during chapter 2, unit 2, I will teach you a shortcut. And you will never have to do this again, except for when I make you on a test or an exam, or they show up on the AP test and they say, hey, use the definition, blah, blah, blah. And you're like, what? That's when we're going back to this. So we'll get back to it. We'll talk about it a lot. Don't freak out. I hope that these quick hits were helpful. So we talked about, again, about this weird delta x thing. And then this funky limit with radicals and the absolute value. So the first two are really more for your sort activity, and the last one is for the WebAssign. Hope you're having a great weekend. I will see you guys all very soon.